In this video, I'll be showing you how to use the Bashforth or AB-4 method to solve for an ordinary differential equation, or ODE, given an initial value problem. And so before we proceed, I recommend that you either copy this table down here, just so that it becomes easy when you want to input values later throughout the video, or you can also download this Excel file which I've shared in the description below. And so the Excel file comes complete with all of the workings ready. But again, I recommend that you follow through with this video to understand where we got those values from. Right, moving forward, we have an illustration here, which I think is important to look at first to truly understand how we're using the Bashforth formula and why we're using it. So we have this person here who's climbing up a mountain, and we know that at the base of the mountain, or x equals 0, the person is at a height of 1. Now what we want to figure out is that at the peak of the mountain, or x equals 2, what height is that person currently at? And so we can use the AB-4 formula to model that. Here we're given our problem, which is the ODE we need to solve for. Right here, we're given the Bashforth formula, which is quite long, but again, trust me, it's actually much simpler than it looks. And we have the Euler formula, which we're going to have to use first for our first few iterations, and I'll show you why in just a minute. We also have our parameters, which are the initial values, so x0 and y1, and we have our step size, which is 0.1. Now h, or the step size, is simply just the distance covered per iteration, or maybe to more easily visualize it, the steps taken, the distance taken per step of the person here. So meaning if the person is climbing up the mountain, per step, the distance covered is 0.1. So 0.1, 0.1, 0.1, 0.1, so on, until we reach x equals 2. And we have our range here. So we want to iterate from the base of the mountain, 0, up to the peak of the mountain, 2. Right, with that, let's move on to the iteration table. And first, we have to link our initial values to this table. So take our x0 here, and we also reference our y0, our initial value, which we know to be 1. Okay, so at x equals 0, y is 1. Here, we're simply just evaluating the function. So we're taking the ODE and replacing these x and y values with our x and y values. So it's simply just x squared plus y, like this, right? Replacing x here with x here, replacing y here with y here. And here, it's simply just h. So take the step size here, $sign it, since it's constant, multiplied by our previous evaluation, like this. Okay, now the second xi is simply just the previous xi plus the step size, and $sign that too. Okay, and our yi is, how we predict our second yi is not through the AB-4 formula first, but through the Euler formula. And the reason being, if you take a look at the AB-4 formula, we need 4 sets of evaluations, meaning we need to evaluate the function at xi, yi, xi minus 1, yi minus 1, xi minus 2, y minus 2, xi minus 3, yi minus 3. Meaning we need 4 of these values, while currently we only have one evaluation, right? And so we can utilize the Euler formula first to gather up all these evaluations, since the Euler formula only needs the previous yi and the previous evaluation. So we're going to do this to get the first 4 evaluations first. So take this, press equals, take your previous yi plus this here, h of f xi yi, which is simply just this formula, right? Okay, press enter and copy the remaining cells down like this, and repeat this for 2 more times. So simply just highlight everything like this and copy it down twice. You can drag it with your mouse or just Control D. Okay, now since we have 4 evaluations already, then can we proceed with using the AB formula. So this stays the same, so just copy this down here, and yi is now the following. It is the previous yi here, plus h divided by 24 here. So take h, $sign it, divided by 24, multiplied by the following. So 55 multiplied by this here, minus 59 multiplied by this here, plus 37 multiplied by this here, minus 9 multiplied by this here, like this. And let's take a look at this one more time. It's simply just this formula, right? So yi is k16 plus h divided by 24 multiplied by 55 times this, minus 59 times this, and so on. So it's just copying this formula right here. And with this, we're basically done. We can just copy this down here and copy the remaining cells as well. So take all this, highlight it to the bottom of the table, and Control D. Okay, and we get the following. So we get that at the peak of the mountain, or x equals 2, the person is at a height of 12.03, let's say meters in this case. And so we've successfully used the AB-4 formula to model this ODE. That is it for this video. I have some other videos on different numerical methods, such as the AB-2, the Euler method, Newton-Raphson, bisection, bracket, and so on. So if you're interested, please take a look at those as well. And yeah, thank you for watching.